I'm Junjie Hou. Here's my solution for homework 5 question 1. In this question, the density function of x is step function x minus 1 minus step function x minus 2. And the density function of y equal to uy minus uy minus 1. The question is need to find out the density function of z. First, we can calculate the density function of z by the convolution method. Here is the convolution method. First, we can draw the diagram of fx and fy. It's like this, and in order to the density function of z is equal to fz convolution fyz. In order to calculate this convolution, we can first shift the density function of x to left by 1, so we get this diagram. Then we use the equation of convolution to calculate fz prime. By doing this integral, it's equal to integral from minus infinity to infinity u alpha minus 1 multiple u z minus alpha minus u z minus alpha minus 1 d alpha. When we calculate this integral, we finally get the result is this z multiple uz minus z minus 1 uz minus 1 minus uz 1 multiple uz minus 1 plus z minus 1 multiple uz minus 2. Then we can shift this result to right by 1 to get the real density function of z. The result is this. The second method is a geometric approach. In order to calculate the density function of z, we can find out the distribution function of z by the geometric method. First, we know that the distribution function of z equal to the probability of capital Z less or equal z equal to multiple probability of x plus y smaller or equal than z. For z less or equal than 1, we can draw this diagram. This is unit square, and x plus this line represents the function of x plus 1 equal to z. The shaded area is the probability of capital Z less than z. So the distribution function of z when z smaller than 1 is the space of this area is equal to z squared over 2. and the density function of z prime is equal to the differential of distribution function of z equal to z. And for the case of z larger than 1, smaller than 2, we can also draw the diagram, and the shaded area, which is this area, is also the probability of x plus y smaller than z. So the distribution function of z equal to minus z squared over 2 plus 2z minus 1. We can also calculate the differential of this function, get f prime z equal to minus z plus 2. And for the last case, for z larger than 2, the probability of x plus y smaller than z is equal to 1. All the unit square is included in the shaded area, so the fz prime equal to 0. Sum all these three results, we can get the diagram of fz prime, which is like this, and I also can shift it to right by 1 to get the real result of distribution function of z, which is this. So this is the solution for question 1.